And the crazy part is, they were retraining their recommendation models daily. Daily, Shrija! Can you imagine the chaos if they weren't meticulously tracking every single experiment?
Daily? That's intense. Who are we even talking about here? And what kind of scale are we looking at? Because daily retraining sounds like a recipe for disaster without serious infrastructure.
We're talking about Netflix, of course. Millions of users, personalized recommendations, and a constant arms race against churn. Now imagine this. You're a data scientist at Netflix. You tweak a hyperparameter, run an experiment, and it works. Engagement jumps. But wait, which hyperparameter was it exactly? What data did you use? What version of the model? If you can't answer those questions instantly, you're dead in the water.
Okay, I see the problem. So without experiment tracking and a model registry, you're basically flying blind. It's like trying to bake a cake without a recipe, hoping it turns out the same every time. You might get lucky once, but good luck replicating it consistently.
Exactly. And the cost of failure isn't just a bad cake. Think about it. Wasted compute resources, non-reproducible results, model drift leading to poor recommendations, and ultimately, unhappy users leaving the platform. It's a business-critical problem.
So let's break this down. What exactly is experiment tracking? Is it just glorified note-taking?
It's note-taking on steroids. At its core, experiment tracking is about meticulously logging every detail of your machine learning experiments. We're talking hyperparameters, code versions, data sets used, evaluation metrics, and even environment configurations. Everything needs to be recorded.
Okay, that makes sense. But how is that different from just having good coding practices and commenting your code thoroughly?
That's a great question. Good coding practices are essential, absolutely, but experiment tracking tools automate and standardize the process. They provide a structured way to log information, visualize results, and compare different experiments. Think of it as Git for your ML experiments. You can branch, merge, and revert to previous versions.
Git for ML experiments. I like that analogy. So what are some common tools for experiment tracking? I've heard of ML Flow, but are there others?
MLflow is a big one, definitely. It's open source and provides a comprehensive platform for tracking experiments, managing models, and deploying them. But there's also Weights and Biases, which is popular for its interactive dashboards and collaboration features. And then you have cloud-specific solutions like SageMaker Experiments on AWS or Vertex AI Experiments on Google Cloud.
So it's not just about what you track, but also how you track it. The tooling seems critical for making it manageable at scale. What about model registries? Where do they fit in?
The model registry is where your successful experiments go to live. Think of it as a central repository for your trained models, along with their metadata, lineage, and versions. It's the single source of truth for your production models.
Okay, so experiment tracking is like the messy workbench where you're tinkering, and the model registry is the neatly organized display case for your finished products.
Exactly, you nailed it. And here's the crazy part. The model registry doesn't just store the model file, it stores everything you need to reproduce that model, including the code, the environment, and the training data.
But wait, doesn't that mean you're essentially duplicating a lot of the information that's already in your experiment tracking system? What's the point of having both?
That's a valid point. There is some overlap, but the key difference is focus. Experiment tracking is about exploration and discovery. The model registry is about production readiness and governance. You want to ensure that the model you're deploying is the exact model you tested, with a full audit trail.
Okay, that makes sense. So it's about formalizing the process and ensuring compliance. Can you give me a real-world example of how a model registry helps with that?
Absolutely. Think about a company like Stripe, which uses machine learning to detect fraudulent transactions. They need to be able to explain exactly why a particular transaction was flagged as fraudulent. A model registry allows them to trace the model back to its training data, its hyperparameters, and its evaluation metrics, providing a clear and auditable explanation. This is crucial for regulatory compliance and building trust with their users.
So it's not just about reproducibility, but also about accountability. What about versioning? How does the model registry handle different versions of a model?
Versioning is absolutely critical. Every time you retrain a model, you create a new version in the registry. This allows you to track the performance of different versions over time, compare them side by side, and easily roll back to a previous version if something goes wrong.
So it's like Git for models, but instead of code, you're versioning the entire model artifact and its associated metadata.
Precisely. And here's where it gets interesting. Most engineers think of versioning as simply incrementing a number, V1, V2, V3. But the real power of a model registry is in semantic versioning. You can tag models with meaningful labels like production, staging, or deprecated. This allows you to automate your deployment pipelines and ensure that only the correct models are being served.
Okay, that's a subtle but important distinction. It's not just about tracking versions, but about managing them intelligently. So if Stripe detects a sudden spike in fraudulent transactions, they can quickly roll back to a previous version of their model that was known to be more effective.
Exactly. And they can do it with confidence, knowing that the rollback process is fully automated and auditable. Now, let's talk about another crucial aspect, collaboration. How do experiment tracking and model registries facilitate teamwork among data scientists and engineers?
That's a great question. I imagine it helps break down silos and improves communication, but can you give me a concrete example?
Think about a large team of data scientists working on different aspects of a recommendation system at, say, Amazon. Without a centralized experiment tracking system, it's easy for them to duplicate efforts, use inconsistent evaluation metrics, and even override each other's work.
Sounds like a nightmare. So how does experiment tracking solve that problem?
By providing a shared workspace where everyone can see each other's experiments, compare results, and collaborate on model development. They can easily reproduce each other's work, identify promising approaches, and avoid reinventing the wheel.
Okay, so it's about fostering transparency and knowledge sharing. What about the handoff between data scientists and engineers? Is that where the model registry comes in?
Absolutely. The model registry serves as a bridge between the research and production teams. Data scientists can register their trained models in the registry along with all the necessary metadata. Engineers can then easily access these models, deploy them to production, and monitor their performance.
So it's about streamlining the deployment process and ensuring that the models are deployed consistently across different environments. What about continuous integration and continuous deployment, CI/CD, for machine learning models? How do experiment tracking and model registries fit into that picture?
They are absolutely essential. Experiment tracking provides the data you need to automatically trigger retraining pipelines based on model performance. If your model's accuracy drops below a certain threshold, you can automatically kick off a new experiment to find a better model.
Okay, so it's about automating the entire ML lifecycle, from training to deployment to monitoring. What about monitoring? How do you ensure that your models are performing as expected in production?
Model registries often integrate with monitoring tools that track key metrics like accuracy, latency, and throughput. If a model starts to drift or exhibit unexpected behavior, you can automatically trigger an alert and investigate the issue.
So it's about proactively identifying and addressing problems before they impact your users. This all sounds incredibly complex. What's the one thing that most engineers get wrong when implementing experiment tracking and model registries?
Let me think. They treat it as an afterthought. They focus on building the model first and worry about tracking and versioning later. But the reality is, experiment tracking and model registries should be baked into your ML development process from day one. It's like building a house without a foundation. It might look good at first, but it won't stand the test of time.
Okay, so it's about shifting your mindset and treating these tools as essential infrastructure, not just optional add-ons. So what are 3 practical things that a software engineer can do differently after listening to this?
First, start tracking every experiment, even the ones that fail. You can learn just as much from failures as you can from successes. Second, standardize your evaluation metrics. Make sure everyone on your team is using the same metrics to measure model performance. Third, automate your deployment pipeline. Use a model registry to manage your models and automate the process of deploying them to production. Think of it as automating your way to MLOps nirvana.
So track everything, standardize your metrics, and automate your deployments. Simple, but powerful.
Exactly. And remember, a well-managed ML system is a reproducible ML system.
I like that. A well-managed ML system is a reproducible ML system. That's going to stick with me.